Good morning, students. Welcome to the last part of solving the specimen paper, paper 14024 for examination from 2018. Today I'm going to solve from question number 18 and onwards. Now, question number 18 says evaluate 5 over 3 whole to the power minus 2. So indices rule says that when we have power minus 2, we can change this power to positive, and then this is going to be turnover. 3 is going to go on the numerator and 5 is going to go to the denominator. So it's going to be 3 by 5 whole square. So 3 square, if I take the bracket off, 3 square and 5 square. Square is going to be on both of them. So 3 square is 9, 5 square is 25. So final answer is 9 by 25. So that's my final answer. And this one, 18b, simplify 9 over t to the power 6 whole to the power half. That means 9 can be written as 3 square, and if I take the bracket off, this is half, and t to the power 6 then times half. So this 2 cross out, and this 2 this 6 comes 3. So it's going to be 3 over t to the power cubed. So this answer would be 3 t to the power cubed. That's final answer. Now simplify 2x to the power 3 y over 6x y to the power 2. So I can cross this 2 and 6, and I have 3 in the denominator, and there are x to the power 3, and in the denominator x equal to 1. If I cross that 1 out, it's going to be x squared. That's in another way of saying x to the power 3 divided by x. That means, and power of x over here is 1. So x to the power 3 minus 1, that's going to give me x squared, or crossing that out is same thing. Now y and y square y. So on the numerator I have x squared, and the denominator I have left only 3y. So that's going to be x squared over 3y. All right. Now this is an interesting question, symmetry, line of symmetry. This type of math, most of the time you have to do trial and improvement method, okay? Or there are some other ways. I'll show you this one. In this diagram, two small triangles are shaded. See this triangle? And there are so many small triangles inside there, and two of them are shaded. Shade one more small triangle so that the diagram will then have one line of symmetry. So one line of symmetry. This is, look at this, 1, 2, 3, 4, 4 bases of the triangle, 4 bases of the triangle, and 4 small bases of the triangle. So this is actually an equilateral triangle, and we know that equilateral triangle have 3 line of symmetry through the vertex to the opposite side. So this one, 3. Okay. Now whenever you are drawing one more or shading one more triangle, okay, to have one line of symmetry, so I'm going to have only one line of symmetry. If I draw that, see that this triangle falls into this one. So if I shade this one, then this falls in that one. So I need to draw or shade two of them. So this is not the line of symmetry I want. Okay, what about if I want this line of symmetry? If I have this line of symmetry, this half triangle falls in this half triangle, and this is going to be falling in this triangle. Okay, then I'm going to have one line of symmetry. Okay, the rest is over here, so it doesn't work. This is the one I want. Okay, so this is the triangle get shaded so that I'm going to have only one line of symmetry, and this is my line of symmetry. Okay, so trial and improvement method. Now question B said, in this diagram, two small squares are shaded. Shade two more small squares so that the diagram will have rotational symmetry of 2. Now this is a square because see the smaller squares alongside or horizontally there are 4 and vertically 4. So these are 4 small squares making this bigger squares. So when I have a square has 4 rotational symmetry. Okay, from this center, if I go from this to that 90 degree, and from this to that another 90 degree, from this to that 90 degrees. So there are 4 line of symmetry, rotational symmetry. So if I rotate through this is the center. See, this is the middle of this horizontal line and middle of this vertical line. So this particular place is my line of center of rotation. Okay, so if I hold this, I hope you can see that. Okay, can you see this part? Okay, so that's my line of center of rotational symmetry. So if I rotate that, see that it comes over here and rotate this, so it doesn't work. I have to do some trial and improvement method. Now this one, see, from this, if I rotate this way, from the left side top corner, this is empty and this is second one. And over here I need from this empty, I go back that, so this second one I need that. Okay, so I shade that. And next to that, so this is actually that one, so next to that should be over here. Now let's see whatever I do is correct or not. If I hold it like that, see that on my left hand side top corner I have, not top corner, one below top corner, I have two shaded region, and just below my right hand side corner to the shaded. Okay, so this is 90 degree. It's, you can see that it doesn't fit, it doesn't. Okay, let me go and do that again. Okay, this is my center of rotation. Okay, this part. Okay, now if I go 90 degrees, see that it changes from the side way, it goes the vertical way. So this is not the one I want. But if I rotate it 180 degree, so that actually the same thing. Look at this 180 degree, and then if I go back to original position, they're the same. So this is two rotational symmetry. Okay, so we are okay if we do this thing. Now, next one is net. This is a new topics that was added last year. Question number 20. Amil is drawing an accurate net for the triangular prism shown. All the lengths are in centimeter. On the grid opposite, complete the accurate drawing of the net for this prism. One face has been drawn for you. When one faces is drawn, then our choices are limited. So this one could be this triangle over here, and it's upside down. So what I'm gonna do, I'm gonna count that. See that 3, 4, and 5. See, hypotenuse is 5 and the base is 3, height is 4. So 1, 2, 3, this is my 3. I just do that to show you something. 1, 2, 3, 4, this is 4, and this Pythagoras theorem, this is 90 degrees, so this is 3, this is 4, this must be 5, and this is 5 right over here. Now along with this 4, I have this line 6. See that 6 unit? So this is 4. What I'm gonna do, I'm gonna go line 6 units, one line with 6 units. 1, 2, 3, 4, 5, 6. So it must be here, and from here again 1, 2, 3, 4, 5, 6. Because this is a rectangle. It does look like a parallelogram, but you should know this. This is a three-dimensional problem. So that's 90 degree. That's 90 degrees. So it's gonna be a rectangle like this. I'm going to just use my scale to draw this. You can draw freehand. It doesn't matter because it doesn't has to be political correct. Only the shape, the way it's supposed to be. If it's correct, it's okay. So that's that. Now I need to understand that when I fold this, this is gonna make these two sides gonna be same. So if this is 3, I'm gonna have 3 unit this side. So up to here, that's 3. I'm gonna prolong this side a little bit more, 3 units more, and this is 4. And if I join this, then it's going to be this diagram, this solid or this object over here with this rectangle and two triangular sides on each of them. Okay, now 6, if I cut it, this 3 gonna come over here. You can see that this 3, okay, over here. So down below I'm gonna draw 3. Actually that's upside down. This is 3. When I fold it, it should have a 3 unit line over here. So 1, 2, 3 right over here, and this one 3, 4, 5. So this prolong, I'll just prolong this one, and then this is the line. So when I fold this, cut it and fold this 3 will coincide with this, and this 3 will coincide with this. Now over here, see that how many surface do I have here? I hope you can see that there are 2 triangles, this one and this one, 2 triangles, and this is a rectangle, that's 3, and this is another rectangle that's on this base 6 and this hypotenuse, so this one. So 2, 3, 4, and another base at the bottom, that's another rectangle. So 1, 2, 3 rectangles and 2 triangles, total 5 surfaces. Okay, and I have 2 of this and I have 2 of this. I need 1 more. So which part is gonna be drawn over here? So I have 4 and 3. One left is 5. So this particular length is gonna be 5. 1, 2, 3, 4, 5 over here. 1, 2, 3, 4, 5 over here. So that's 5. Now you can see that if I fold this 5 and 5 coincide, and this 5 coincide, and 3, 3 coincide, and 3, 3 coincide, and this is 1, 2, 3, 4, 5, 6, this 6, and this is 6. So when I fold it, this 6 coincide with this thing coincide with that. So this is the net of this particular object. Okay, let's do the next one. Question number 21. A machine puts beads of different colors and sizes into packets. The beads are selected at random from a large container, and the selection of each bead for a packet is independent of all others. The table shows information on the contents of 6 packets, the packets 1, 2, 3, 4, 5, 6, and total number of beads. There are 15, 14, 19, 18, things like that. Total is 100. Number of blue beads is 6, 5. These are, I don't have the total. So let's calculate the, okay. So let's count them and put the total. 6 plus 5 is 11. 11 plus 8 is 19. 19 plus 6 is 25. 25 plus 8 is 33. 33, 7 is 40. Okay, calculate the relative frequency of the machine selecting a blue bead. So blue bead, there are 40. So I'm gonna write down 40 over here. This is relative frequency. Okay, this one relative to the total number, that's 100. So over 100, I can cross this, and then 4 divides by 2, 10 divides by 2, that's 5. So 2 by 5. So this answer is 2 by 5. Relative frequency. This is the frequency of blue out of totals. So 40 divided by 100, that's 2 by 5. Now calculate how many blue beads you would expect if in a packet of 30 beads. Okay, so this is the probability. This is the relative frequency, and 30 packets bead. So what can I expect? Okay, now this is for one packet. Okay, if it's in one packet, then what I'm gonna do for 30 packets, I'm gonna multiply this relative frequency, this part, with this 30 bits packet. So 2 by 5. So 5 cross out, that's 6. That's gonna 30. So 6 times 2 is 12. So I can expect 12 bits, blue bits, in a 30 bits packet. Okay, so that's 12. Now the probability that the machine selects a red bead is 0.17. The machine's probability to select a red bead is 0.17. Calculate the probability that the machine does not select a red bead. So we know by the formula that probability of happening some event A and probability of not happening that something A is always equal to 1. So the probability of getting a red bead is 0.17. So not selecting a red bead, so probability of not selecting a red bead is going to be 1 minus probability of selecting a red bead. And 1, this is minus 0.17. So if we subtract that, so 1.00, then 0.17, that's going to be 3, and that's going to be 8, and that's 0.83. So this answer would be 0.83. Okay, that's final answer. Now this is our constructions. Okay, and locus. The diagram at the bottom of the page shows the lines AB and BC. This is AB and BC. You can see that it's not perpendicular. By measuring, okay, measure. So when it's measured, then an angle. So you need the protector. Measuring, find the reflex angle. ABC, reflex angle. Reflex angle is, reflex angle means it's greater than 180 degree. Okay, it's always greater than 180 degree. Of course, less than 360 degree. So when I measured this, see this line over here, this line, and perpendicular to this line, this point over here, this point should be on this, and this line should be coincide with that. So if I do this, I got actually this line more or less 91, 92, 93, 94. So I got about 94. Yeah, I got 94 degree. Okay, so this one is 94. Now this angle ABC, this is my reflex, this is my obtuse angle. Obtuse angle is greater than, okay, let me write down, greater than 90 degree but less than 180 degree, and reflex angle is less than 360 degree but greater than 180 degree. So this is obtuse, I want this one, and together makes 360 degree, a complete angle or a pentagon angle. So 360 I'm gonna just write down here 360 minus 94 degree. So that's gonna be 6. That's it's gonna be 264. I got 264 degree. Okay, it might not be equal to your mark scheme because sometimes the measurement, if it's a little off, then it's not going to be matching. So there should be a range of values given. Okay, the point D is on the opposite side of AC to B. Now over here is AC, so B is this side. This is AC, B is this side. So D is gonna be opposite side. So this is my AC. Let me just show that. This is AC line and B is this side, but D is gonna be opposite side of B. So this side, somewhere over here. CD and CB equal. So CD, let me just underline that. CD equal to CB. So C to D and C to B. These two are equal. And AD equal to 10 centimeters. So what I'm going to do, I'm going to first draw a line that's 10 centimeter long. I can draw it over here. Okay. So this from 0 and that's going to be 10 right over here. So that's my 10 centimeter right over here. Okay, so I'll take this compass and I have this pencil attached to it. So what happened? First one, CD equal to CB. Let me measure CB. So I'm gonna put over here my pointer of the compass and measure this radius till B or CB, and then I'm gonna just draw an arc like this. That's length of CB. Okay, so that's that. And then AD equal to 10 centimeters. So I'm going to measure this one, take that measurement, and I should have a marking over here. So AD from A. So I put my pointer over here and I just join that. So that's a palm tree like of thing. And this is my AD, and you can clearly see that D is on the opposite sides of B. So that's okay. And okay, I have to construct the quadrilateral. So I just join that, CD join and AD join. AD join. So that's my quadrilateral ABCD. Now on the diagram, construct the locus of the point inside the quadrilateral that are equidistant from A and B. So when it's equidistant from A and B, then perpendicular bisector of AB. So to get that, I need to have an arc that's more than half AB. Just a guess would be fine over here. I'm going to draw an arc length over here and draw arc length over here. So on the both side of AB, I'm going to draw that with the same radius. I'm not going to change that radius. From center A, I'm going to draw two more arc length to intersect the previous one. I hope you can see those. And I'm going to join these two points, and that's that. This line, any point on this line is going to be equidistant from A and B. Now it's equidistant from BC and BA. BC and BA. So center is B. This means this one was perpendicular bisector and this one is angle bisector. I need to bisect this angle. Again, what I'm going to do, pointed on B, I'm going to draw an arc intersecting AB at some point and BC at some point. And from this, with any radius, I can take the same radius or more than half of that. I'll take a little bit more. So draw an arc over here, and with the same radius now, from here, I'm going to draw another one. So this point and this point, I'm going to join it. So it's going to be something like that. Okay, this on this line, any point that's going to be equidistant from BC and AB. Okay, so that's done. On the diagram, shade the region inside the quadrilateral ABCD containing the points that are nearer to A than B. So this line bisect the distance. It's just divide the distance of AB. So this part, left side of this line is closer to A and this side is closer to B. So nearer to A. So I'm looking this part, not this part. Okay. And the nearer to BC. So this side is BC and this side is B. So this side. Now they are talking about this side and this side. So this is the region they are talking about. So I'll just shade this part, and that's the shaded part. Okay, so that's done. Now, question number 21. Find one value. One value. See that it's bolded. One value of x. So there might be more than one value. So you need to find out just one value, that both x is greater than 4. So I'm going to just draw a number line. Sometimes it's better. This is 4, and that's where somewhere it's going to be 0. Okay, just to show that this side is going to be less and this side is greater. So this one is saying greater than 4. So I'm going to have an open circle. Greater than 4 means any values over here. Now this one, what I'm going to do, I'm going to just solve this one. 17 minus 4x, then greater than 2 minus x. Bring this x to that side. So that's going to be x minus 4x, and take this 17 to that side. So 2 minus 17, I'm going to have over here minus 3x, and here is minus 15. Don't cross that out. In equation we can do that, but in inequality we cannot do that. So x, when I taking this minus 3 to the opposite side, this is multiply with the x, so it's going to be division. When I divide with negative sign, then this sign changes. Okay, and negative negative cross out, and this cross out, 5. So it's x is less than 5. So this is 5, and it says that x is less than 5. So this part over here. So what happened? One of the inequality said x is greater than 4. Another one says x is less than 5. So any values in between. So I can take x to be 4.5. That's one possible answer, and that's what they're asking. You can give 4.1, 4.2, whatever you want. Okay, find the highest common factor of a factor or HCF of 36 and 54. There are so many ways you can do that. What can I do? I just put that one, and 2 goes in 36, 1, 8, and 2, 7. I have to find any factor that's are common for both of them. So 2 is factor of that, but not this one, but 3 is a factor of both. So 3 is going to be 6, and 3 is going to be 9, and over here 3, 2, and 3. So HCF, I'm going to take only the common factors, only this. Okay, for LCM I would have gone for all of them. So HCF is going to be 2 times 3 times 3. The 3 3s are 9, 9 2s are 18. So this is going to be 18. Okay. Now this one, estimate. So they are not asking for the exact value. Nearest whole number to the nearest whole number. These are very important of the value of this. So square root 97 minus square root 35. So what is the closest to the 97 is a perfect square? It's 100. So I'm going to write down over here approximately equal to. And closest perfect square is 36. So I can take this one off and write down 10, and that's going to be 6. So it's 4. So this answer is 4, estimated. Okay, not to be exact. Okay, so 4. All right, now question number 25. And it's saying that this AOB 132 and this is 59. I have to find out ATB. So where is ATB? ATB is this one, ATB. Now from T, we can see that these are tangents at A and B. So when it's tangent, it's make with the radius 90 degree. So that's 90, 90, and this is a quadrilateral. Sum of all 4 angles of a quadrilateral is 360 degree. I already have 90, 90, 180. So this two must be 180. So this angle, 180 minus 132. So 180 minus 132, that's going to give me 8. So that's going to be 4. Okay, and that's going to be 0. So 48 degree. Okay, that's done. Find BDA. BDA, this angle. Now, if I look closely from this arc length, this angle at the center is 132, and from the same arc length, there is this angle at the circumference. So this must be half of that one. So that's going to be half of 132. That's going to be 66 degree. Okay, so that's going to be 66 degree. And BDC, BDC, this angle over here. Now, this one from this arc length, BC, this is at the center and this is at the circumference. So it should be half of that one. Since this is a diameter, it goes through O, it's a diameter, should be written somewhere. Okay, but if it's O, O is the center. So this is the diameter. So this is 180. This particular angle should be 180 minus 132. So that's going to be 848. So this is 48 ATP. Okay, so this is going to be half of that. So half times 48, that should be 24 degrees. So this is 24 degree. Now it's asking OBD, this angle, OBD, this angle. So I have this one. There are so many ways you can do that, but I'll just do this one. This is 24, this is 59. So I can get this angle. Let it be theta. So this theta would be 180 minus sum of these two. 59 plus 24. So 180. So that's going to be 13, 3. So 6, 7, 8, 83. So that's going to be 97 degree. This is 97 degree. Now these two are vertically opposite angle. This is also theta. This is 97 degree. So this angle OBD is going to be 180 minus 97 plus 48. So that's going to be 180 minus 8 and 7. That's 5, 15, carrying 1, 10, 14. So 145. So this is going to be 35 degree. So that's 35. Okay. And the last math, the diagram in the speed time graph of part of the train journey is showing. The train slows uniformly this 50 meter per second to 10 meter per second within 20 seconds. During the 30 seconds, it accelerates uniformly to the speed of u. Okay, this part. Calculate the deceleration from t0 to t20. So deceleration. So deceleration is negative acceleration. So deceleration could be that 10. So we can go for acceleration, we can go v minus u divided by t, and deceleration we can go u minus v divided by t. Okay, it doesn't matter, you can use that one. And when let me use this one. Okay, so I'll just show you what I mean. Okay, acceleration is v minus u divided by t. So v is my 10, u is 50, and this thing happens in 20 seconds. So that's going to be minus 40 divided by 20. So cross this out. So 2, negative 2 meter per second. Since it's deceleration, I don't need to show negative. So I'm going to say 2 meter per second square. Okay. If it was saying acceleration in this stage, then I would have said minus 2 meter per second square. Okay. Now calculate the speed of the train when t equal to 15. See that 15 would be somewhere over here. Okay. And they are saying what is the value of speed over here. Again, we're going to use the formula a equal to v minus u divided by t. So acceleration was negative 2, and v I don't know. That's what I'm going to find out, v. And u was 50, and this is 15. Okay, so if I cross that one out, if I cross multiply that, it's going to be minus 30, 15 times 2, 30, and that's plus 50 equal to v. So v equal to 20 meter per second. So this is going to be 20 meter per second. Well, I have this in it, but anyways. Okay, calculate the distance traveled by the train from t0 to t20. So over here. Now, speed time graph, we know that the distance covered that actually equals to the area under the graph. So this is looking like a trapezium. So area of the trapezium is going to be distance covered. So that's going to be distance covered equal to area under graph. So that's a trapezium, and trapezium formula is half times summation of the perpendicular lines, summation of the parallel lines times perpendicular height. Now this, if I hold it this way, so 10, this is going to be what? This is going to be 10, right? So this is 10. I'm going to write down here one of the parallel line, and another one is 0 to 50, that's 50. And then height is going to be 0 to 20. So this is going to be 20. So cross this out, that's going to be 10. 60 times 10, that's going to be 600. So within this duration, it covers 600 meter. Okay, the size of the acceleration is half the size of the deceleration. So this is the acceleration, this is the deceleration, this is the acceleration, and it says that the size of acceleration, this acceleration is half the size of deceleration. Now deceleration was minus 2 meter per second square. So acceleration is gonna be half of this size, half times 2, that's gonna be 1 meter per second square. Okay, now it says that find the value of u. So we wanna find out u. So it's saying that acceleration equal to v minus u divided by t. Acceleration is 1, and this v is see, final velocity right now is u, and then initial velocity was 10 and time was 20 to 50. So 50 minus 20. So if I just do this one, this is going to be 30. 30 times 1 is 30 equal to u minus 10. So u equal to 30 plus 10, 40 meter per second. So that's going to be 40 meter per second. Okay. So that's it for this paper. I'll see you in next video for a specimen paper 2 solving. Thank you. Have a good day.